To get audio in, I'm just going to stuff audio into one of the ADC, the analog to digital converter ports, and we may as well pick ADC 0, that's GPIO pin 26, physical pin 31, and I'm just going to adjust the external volume to prevent the input clipping. Just to get some audio out of the Pico, I'm going to refer to the hardware design guide, and down here on section 3.4, the audio section, they've got a nice little circuit that takes a PWM output and essentially low pass filters it so you get some audio out. We don't need all of this. This has got buffers and it's stereo. We'll do without those. We'll just use some resistors, so you've got a potential divider and a low pass filter essentially, and that gives you an audio output. Right, I've breadboarded up that little circuit, so I've got my input jack just connected to ADC 0, which is GPIO pin 26, physical pin 31, and I've randomly chosen GPIO 10, which is pin 14 as my output. So I've got an output divider, this resistor and this one here, and the low pass filter and an output jack. I've loaded up the PWM audio example from the Pico Extras library, and if I power up the Pico, there, we're getting a nice sine wave, so my little output circuit's working fine. Excellent article here by Phil Schatzman in his blog about outputting audio from the Pico via PWM, but using a callback timer so it runs at a regular sample rate. And so I'm using this as the basis for testing a delay. So I've taken Phil's code and pasted it in here, and in main I'm just creating a buffer, 128K, so about half the available RAM. And then in his default audio callback, for a start I'm running this at 22 kilohertz as opposed to the 10 kilohertz that Phil was running it at. And in here I am reading from the analog input and writing that to some point in advance of the current read pointer, so that the read pointer will catch up with it sometime later, and that's where my delay is. And then the read pointer is just reading something that was written a while ago and outputting it via the PWM output. So I've got the input coming in here, and I've just got a kind of random sequence running. And that's being sampled and output half a second or so later, sounding like this. So if I remove the input, you'll hear about half a second of sound before it stops, and that is my delay. And if I bring in the original, hopefully you can hear that there are two signals there. There's the original and a delayed version. However, all's not well. If I feed a sine wave in and look at the output, it looks like this, which is pretty nasty. So let's find out what's going on. Okay, so the problem I've got is that the output from a Eurorack synth swings around a 0 volt level. So here we've got a negative however many volts, and here we've got a positive however many volts, and this can swing up to plus or minus 5 volts or so, about a 10 volt peak to peak swing. So the problem is that once this gets into the GPIO, the GPIO is expecting a voltage between 0 and 3 volts here, and so all it's going to see is the top half of this, the bit above 0 volts. So we need to AC couple and bias this. So what I propose is we take the Eurorack input, we run it through a capacitor. That's going to remove essentially the DC component, so we've then got a floating component, and then we're going to bias it up to plus 3 volts and down to minus 3 volts, down to ground, sorry. Yeah. So 0 volts. And what this will mean is that then we've got a signal, provided we we attenuate it suitably, we'll then have a signal that will hit the GPIO pin looking a bit like this. So it's going between 0 volts at the lowest level up to plus 3 volts. So I'm going to build that. So here we are. I've randomly chosen a 10 microfarad capacitor and 247k resistors. So capacitor removes the DC element, and the 2 resistors bias it between plus 3 volts and 0 volts, and here it is. So this white wire is my input, if you can just see it behind there, little 10 microfarad capacitor output going into the ADC input of the Pi, and the 247k resistors biasing it between plus 3 volts and ground. And this now looks like this. But I'm not happy about that output waveform. If you look at the input, it's a fairly clean sine wave, but the output's all jagged. Now that could be because I need some anti-aliasing filters. It could be to do with the resolution of the analog to digital converter. It could be noise on my breadboard, but I need a better solution. So what I'm going to do is look at better quality analog to digital converters and better quality digital to analog converters. And so that's going to form the basis of the next scene.